All right, so now we're going to graph the piecewise functions. So let's look at this example. Suppose we had this one. F of x equal 2x minus 1 if x is less than 2. And then x plus 3 if x is greater than or equal to 2. Now remember, this part that I'm circling right here, that's your domain. So when I graph this, I'm going to use the top function for any x less than what? 2. And I'm going to use the bottom one for any x greater than or equal to 2. Okay? So there are going to be two parts of this graph. It won't be a straight line. It will be parts of a linear function. It will be parts of a line. When you graph this, though, the point you want to start with is this number you see here. What number do I see here? 2. Okay. So you can graph each one individually. So what I would do is I would write out f of x equals 2x minus 1. That's the first one I'm going to do. So I need to graph each one individually. Now remember, last semester, the semester before, and even the beginning of this class, when you graphed just this right here, that was a line. And the domain was from negative infinity to what? This right here. Don't look at this. Beginning of the course, when you graph this line, what was the domain of this line? Negative infinity to positive infinity. You could use any number for x. But we're graphing piecewise functions. I can't just use any number for x for these. It's got to be in part of this domain that you see. So I'm explicitly telling you what your domain is. So when you graph each one, you can graph each one. You use a t-table. Use a t-table. The number you must start with is the number you see here. What number do you see? 2. So put 2 in both cases. Put 2 in both cases. Now 2 is not in the domain of both, though, but you're going to use 2 in both cases. You know that 2 is not the domain of either, because if I asked you to tell me what f of 2 is, you're going to tell me that you've got to use which function? The bottom one. That's where 2 is. Okay? But you're going to use it in both cases because when you graph it, one's going to be a closed circle and the other one's going to be an open circle. All right. So remember on the one of the worksheets you had to turn today, some of your endpoints were open, some were closed. That's that idea here. All right, let's talk about 2. Now, is 2, when I look at this one, is 2 really in this domain? No, it's not. I'm talking about the top one, man. I'm looking at this one. Is 2 really in this domain right here? No. So you use an open circle here for this one. That one's going to be open. That's the word open. Open circle. Now plug 2 back into it, though. So when x is 2, I get 2 times 2, which is 4. 4 minus 1 is 3. All right, so when I plot that point, I'm going to plot the point 2, 3, but it's going to be open because it's not part of my domain. So plot the point 2, 3 with an open circle, just like this. Just like that. Okay? Now, remember, these are lines that we're graphing, so you really need 2 points. So now you got to give me an x value that's in that domain, though. Give me an x value in this domain. 1. Okay, someone else could have chosen what? 0. Someone else could have chosen -1, and so on. All right, so let's do 0 though. If x is 0, what's my y value? 2 times 0 minus 1 is -1. Okay, so I plot the point 0, -1. So 0, -1 is right here, a closed circle, because that is part of your domain. And then all you do is take the ruler, start from the open circle, go through that other point, and then that's that part of the graph. Just like this, with the arrow though. So that's one piece of the graph. That is one piece of the graph. Now remember, what I graphed here was that top function. Keep in mind that the top function, the domain was strictly less than 0. It couldn't equal 0. I'm sorry, 2, excuse me. It was strictly less than 2, couldn't equal 2. So that's why there's an open circle here. Now let's do the bottom one. This one here. For this x equal 2, is 2 part of my domain or not part of the domain? It's part of the domain. So that's going to be a closed circle. So when x is 2, though, what's 2 plus 3? 5. So I'm going to plot the point 2, 5. So 2, 5 is here with a closed circle, because it's part of my domain. 2, 5 is on the graph for that part of the graph. Now remember, these are lines that we're graphing, so you just need to give me another point to plot. Give me another x value. That's in that domain, though. Let's use something a little bit further than 2. 5, okay. So if x is 5, notice when on the worksheet and on the in-class worksheet that you're going to do today, how I want this to look. So don't be lazy and lose points because you didn't want to do it like I asked you to. You have your notes in front of you. Use those notes. This is how I want it to look. Okay? All right. So when x is 5, what's 5 plus 3? 8. So I'm going to plot the point 5, 8. So 5, 8 is here. 5, 8 is here. And you just draw your line. Notice these are, for the most part, the ones that we're doing right here, those are rays. Remember from high school geometry, a ray has an endpoint and an arrow, right? Don't draw 2 arrows on these things. You start here and then go this way with an arrow. And you're done. There's your function. That is f of x equal 2x minus 1 if x is less than 2, and x plus 3 if x is greater than or equal to 2. That's what it looked like. Now, when we did when we looked at this the other day, how many pieces were in this function right here? 3. So my function would have how many parts here? 3. All right, but for us, when we graphing these, we're only going to look at 2 of them. All right, let's look at another one. Suppose I had this one. Suppose this time that my function is x minus 1 if x is greater than or equal to 2, x plus 2 if x is less than 2. So I want to graph this piecewise function. So it's made up of 2 linear functions. Those are linear, so they're going to be lines. Although when we graph them, they're going to be rays. They'll turn out to be rays instead. The way I want you to show the work is you're going to list each one individually. You're going to say f of x equal x minus 1, and the other one you're going to say f of x equals what? X plus 2. Now you can turn it in without showing that, but you're not going to get your 10 points. And you're going to do your t-table. You can do your t-table. And based on our discussion a while ago, you have to use what number for both? 2. The left side or the right side? Which one's going to have the open circle? The right side, because that's the one that doesn't have the equal sign. So this, when I find this point, when I plot, it's going to be an open circle.
So no equal sign has an open.
Yeah, no equal sign is open. Yep. And this is going to be closed. Because remember, 2 is not part of the domain for that second one, for that bottom one. Because it says x is to be strictly less than what? 2.
So if there's no open sign
If there's no equal sign, open circle. All right, let's grab the first one. X is 2. So when x is 2, what's 2 minus 1? 1. So I'm going to plot the point 2, 1. So 2 1's here, closed circle. How many more points do I need? 1. These are linear. Now I got to choose a number that's greater than equal to 2. So give me another x value that's greater than equal to 2. 4? What's 4 minus 1? 3. So I plot the point 4, 3. 4, 3. And that's here. Now be careful. Some students, when they're not really understanding what's going on here, they're going to draw a line all the way like this with 2 arrows. That's wrong. Because the domain is not all real numbers. What's the domain of this top function? Greater than equal to 2.
So the arrow goes up.
Yeah, you start with this point that you started with, the first one, and goes to this one. So there's your graph. That's that part of the graph. This is your beginning point that goes to this, and there's your ray. All right, now let's do the other one. If x is 2, 2 plus 2 is 4. But when I plot that point, it has to be what kind of circle? An open circle. So 2, 4 is here, open circle. And I need one more point.
6.
I cannot use 6.
0.
0. It's got to be less than 2. So if x is less than 2, so I'll use 0. What's 0 plus 2? 2. So plot the point 0, 2, which is here. And remember, this is the open circle is my starting point. I go to that point I just found, and there's your graph. Now, if you make a mistake and someone said 6, let x be 6, you would have drawn a graph that looked like this. I want you to just follow me for a moment. You would have had it going like this, but that would not be a function anymore because it fails which test? Vertical line test. These are functions. Remember, f of x, g of x, h of x, those are functions. So it's got to pass a vertical line test. All right, so that was f of x equal x minus 1 if x is greater than equal to 2, and then x plus 2 if x is less than 2. All right, let's look at another one. Suppose we want to graph this one. All right, suppose we have h of x equal x plus 3, that's a 3, if x is greater than 1, negative 4 if x is less than or equal to 1. So x plus 3 if x is greater than 1, negative 4 if x is less than or equal to 1. And the work you're going to show me is you're going to list both functions. H of x equal x plus 3. H of x equal what?
4.
Negative 4. Then your t-table. What x value need I use for both? 1. Which one's going to be open? Left or right? The left one, right? And that's one's going to be closed. Because remember, if x is 1, 1's not really greater than 1. 1 is not greater than 1. So that's going to be open. The bottom one is where x equals 1, so that's going to be closed. All right, so let's substitute the value for 1. If x is 1, what's 1 plus 3? 4. But when I actually put that point, it's going to be open. So 1, 4 is here, open. And then give me another x value that's in that domain.
3.
I can choose any number greater than 1. 3, okay. If x is 3, 3 plus 3 is 6. So I plot the point 3, 6, close circle, and then I draw my ray. All right, so there's that part of the graph. Okay, let's do the other one. If x is 1, now you got to remember what we did earlier at the beginning of class. If x is 1, which function do I use? The top one. Remember, that says that y always equals what? Negative 4. So that's going to be negative 4. So I plot the point 1, negative 4. Right here, closed circle. Remember, these are lines, so I need one more point. Give me another value for x. 0? Okay. If x is 0, same thing. What's h of 0? Negative 4. In fact, no matter what I use for x over here, y is always going to equal what? Negative 4. So I plot the point 0, negative 4. And I draw my ray, and remember last semester or the semester before that, y equal a constant is what kind of line? Horizontal. Very good. And so there's your graph. Well, it's got to go, make sure you put in the right direction, right?
Yeah.
Okay. And if you went this way by mistake, you would realize, well, it can't be because it fails the vertical line test. So I did something wrong. Okay. All right, so there's your function, h of x equal x plus 3 if x is greater than 1, negative 4 if x is less than or equal to 1. All right, let's look at this one. We'll do a couple more. Let's suppose that this one, k of x, is 3 minus 4x. Oops, sorry, 3 minus 4x. If x is less than 0, two x plus 1 if x is greater than 0. Right? No equal. Doesn't matter. It's possible you could your domain. Now notice my domain, if I look at it throughout, it's all real numbers except what this time? 0. Okay, good. All right, so we're going to graph each one individually. K of x equal 3 minus 4x, and then k of x equal 2x plus 1. And then I use my t-table. In both of these situations, I have to use what number for x? 0. In fact, in both of them, will both be open, will both be closed, will one be open, will one be closed? Both will be open because there's no equal sign here. All right, let's do the first one, the one on the left. If x is 0, what's 0 minus 4x? 3. Now give me one more x value that's in the domain, something less than 0. Negative 2, okay. If x is negative 2, this is what I get. I get 3 minus 4 times negative 2, right? I'm writing it out. What's negative 4 times a negative 2? Positive 8, and so what's 3 plus 8? What's 3 plus 8? 11, right? So negative 2, 11. Okay, so then I'm going to plot the point -2, 11. -2, 11. And let's say -2, 11 is right here. Now, depending on which coordinate plane, yeah, it's off the chart. Just kind of estimate. I did not mean for it to be that. Oh, sorry. Thank you. -2, 11, right? So it's right here. Oops, open, right? Open. Okay, thank you. Open circle. All right, I need one more point for. I am messing this up, aren't I? 0, 3 is the one that's what? Open. -2, 11 is what? Closed. Okay. All right, and then you plot the point. You graph the line, the ray rather, and you get this. All right. Now the next one. If x is 0, what's 2 times 0?
1. Maybe. 0.
And 0 plus 1 is positive 1, right? So I plot the point 0, 1. Now when I plot it, though, is it open or closed? Open. 0, 1's here. Open, correct? All right. Now keep in mind, it cannot go this way, right? Because we failed the vertical line test. Remember, these are functions, so if it did, you did something wrong. All right, so give me one other point. Give me a number for x, a value for x that's in this domain. 2, 4, doesn't matter. If x is 2, what's 2 times 2?
4.
4 plus 1?
5.
All right, you plot the point 2, 5. 2, 5 is here, closed circle, right? And you draw your ray. So you draw your ray. You get this. Okay? All right, let's look at this one. Let's suppose this time our function is this, f of x equal 2 if x is greater than 4, -2 if x is less than or equal to 4. So y equals 2 if my x's are greater than 4, and y equals -2 if my x values are what? Less than or equal to 4. All right, so you do the same thing you did earlier. You're going to say f of x equal 2, f of x equals -2. Do a t-table. I've got to use which value for x for both? 4. Which one's going to be the open circle? Which one's going to be the closed? Are they both open? Okay, that's one's going to be open right here. And that's going to be closed. Because that one does not have the equal sign, that one has the equal sign. So when x is 4, that says y has to equal what? 2. Now give me another another value for x that's in this domain. 6. When x is 6, y has to equal what? 2. So you plot those 2 points. So 4, 2 is open. And 6, 2 is closed, correct? Now remember, you in previous semesters, you graphed the line y equals 2. Y equals 2 is what kind of line? Horizontal. And notice this is a horizontal ray. All right, let's do the next one. If x is 4, what's my y value? What's f of 4?-2. This time's going to be close, so I'll plot the point 4, -2. closed. I need one more point. Okay, 2, if x is 2, what's my y value? Negative 2. So 2, negative 2 is here. So remember, you always start, you draw your ray starting at that first point you used.
What number did you use for the second one on the second?
When x is 2. It really doesn't matter. You can use any number you want to, right? X in the domain. Y was always going to be what? Negative 2. So you get this horizontal ray, and there's your graph. There's your graph. So that's the piecewise function. 2, if x is greater than 4. Negative 2, if x is less than or equal to 4. And then finally, let's graph this one. Suppose f of x is equal to 5 if x does not equal 3. We did some does not equals earlier. 2 if x does equal 3. Let's think about that for a moment. All right, let's do each one just like we were doing. So you're going to say f of x equal 5 and f of x equal 2, right? And then your t-table in both cases, just like we were doing. Now you're going to have to be a little bit careful with this one, though. So let's talk about the x equal 3. So if x is 3, I'm going to put 3 in both cases. Which one's closed?
Top, first one.
The bottom one, right? Because that's the one that says equal, right? Now I want to ask you this. If x equals 3, what's my y value? No, 2. Now I'm going to ask you this also. If x equals, for this bottom function, what's the only x value I can use? 3. 3 is the only x value I can use. I can't use any other x value like I did the others. So when x is 3, what's my y value? 2. So when I graph this function right here, it's just a point. F of x equal 2 when x is 3 is just a what? Point. 3, 2. Okay? I can't use any other x value for this. Can't use any other x value. Now, let me just go here and let's pick 4 for the moment. If x is 4, what's my y value? 5. If x is 7, what's my y value? 5, just like we were doing. If x is negative 2, what's my y value? 5. If x is 3, what's my y value? 5. But it's got to be what? Open. And I want to show you what happens here. Listen carefully. I picked more points here for a reason. The previous one we did were strictly inequalities, greater than, less than. Here, this says not equal to or what? Equals to. This second function is just one point. That's all your graph is for the second one is just a point. Because I can't use any other number for x, right? Because this says I can only use it if x is what? 3. Any other number, I'm going to have to use the top one. So when I put the point 3, 5, I get this open circle right here. I also get the point 4, 5, which is here, right? Closed. I also get the point 7, 5, which is what? Closed. I also get the point negative 2, 5, which is what? Closed. And what I want you to notice is that this almost looks like a line, except there's an open circle here. That was a little bit more challenging because of the equal, not equal. That's what it looks like.
It actually makes sense once you think about it.
So your
Leave a little gap where it is, and then everything else isn't.
right. So the open circle is here, the closed circle is right underneath. Yeah. So that's what that one looks like. It looks totally different than the others. The reason is because it was a not equal to situation. Okay. All right. So that was the function. F of x equal 5 if x does not equal 3, 2 if x equals 3. Okay? So that was the more challenging one of the others. Okay, so let's go ahead and deal with our in-class worksheet.